All right, so in this video, we're going to be talking about present annuities and future annuities. So first off, like, what is an annuity? What's the difference between an annuity and the compound interest and compound continuous interest? So the difference between the annuity is you're putting in something every month, and then you're building interest on what you're putting on it every month. So you're actually depositing, like, let's say $100 of your paycheck each month is going into this bank account that you're going to gain interest on, and then you're going to pull out in 20 years to use it. Whereas the compound interest and the compound continuously, when we're compounding them, that's putting a set amount in your bank account and then kind of letting it sit there and build interest on its own. Okay, so when we're doing these annuities, just realize we're talking about like monthly money going in to either a bank account to gain money, or we're going to be talking about loans where we're going to be paying off a loan, and we're going to see how much we're actually paying into that loan, because in the loan there is interest. That's why banks do loans. Okay, so we're going to be able to see, like, okay, if I'm doing a 30-year mortgage, then how much extra am I actually paying because I took out this loan that has an interest payment on top of it? And then how much would we be saving if I put an extra $100 into paying it off every month, and so on and so forth. Okay, so what is an annuity? Basically, you're putting in something every month, whether you're paying something off or whether you're putting it into a bank account to gain interest to pull out later. Okay, so our first one is our future annuity. So this is when we're trying to gain money. Okay, so notice when we do this, the original equation that the book gives is going to be the middle one here. So it's a future value in it. Okay, and then I kind of have what everything represents. So R is the money at the time of interest. We have 1 plus I, so the I stands for a rate of principal. So just the K is always going to be that kind of principal. So quarterly, monthly. A lot of times they do monthly because you put it in monthly. So most of the time you're going to be using 12 for that K. Okay, to the N represents K times T. So our time times our time, so like our 30-year mortgage, times the period that we're putting it in. So every month, so the 12. Okay, minus 1 all over that rate divided by the period again. So in all the equations that we're doing, it's always rate divided by the period. So rate divided by quarterly, or rate divided by monthly, or rate divided by days. Okay, so when we actually go in and fill in what all those variables actually mean, this is the equation I'm going to reference a lot more. So we have that R where it's our starting amount. Okay, the amount we're trying to get to is the FV. All right, so 1 plus the rate divided by the time times that periodic time times actual time that you're putting it in there, so how many years, minus 1 all over that rate and that periodic time again. So that 1 plus means we're trying to gain money, whereas when I show you guys the loan formula, it's going to be 1 minus, okay? Because gaining money, we should be getting bigger. If I'm trying to do a loan, I'm paying something off, so it should be getting smaller, okay? So then my next one here is the present value. So here's the big equation the book gives. So the I in this is going to represent the rate over that periodic time. The N is going to be that periodic time times time. Okay, so those I's will be replaced with the rate over that periodic time. And then that N up there is going to be a negative periodic time times time. Notice this is 1 minus, because hopefully we're paying off a loan, we're putting money into something to kind of get that down further. Okay, this is called present value. The present value of what you're going to be paying. And then that R is going to be your monthly payments most likely, or yearly payments, the payments you're putting into it. Okay, so our first one here. Every month, Mr. Michon deposits $120 into an investment fund. If the investment earns 6.4% annually and compounded monthly, what will be the value of the investment in 20 years? So first off, we got to figure out which equation we're using. Are we using the investment equation, or are we using the loan equation? So if I'm putting money into a bank account, I'm not really paying anything off. I'm trying to gain interest on it and then pull it out later. So we're doing the investment route. So I'm going to be using this bottom equation right here. Okay, so if you would like to pause the video to go ahead and try plugging everything in that you think goes where, go ahead and pause the video. Otherwise, I'm going to kind of write it all out and then explain it. All right, so this is what I currently have. So the R is that monthly payment. So that's where my 120 is. It does 1 plus. We're going off of the second equation where it's all filled in, so I can just fill it in. So it's rate over the periodic time. So we're doing it monthly, so 12. If it was daily, there's 365 days in a year. If it was quarterly, it'd be 4, because you think of quarters going into a dollar. Semi-annually is 2. Okay. And then it was to the K times T, so that's periodic time times actual time, minus 1 all over the exact same fraction again. So you notice this R over K is going to be very repetitive when we're doing future value and present value. Okay, so future value, the future value of my bank account in the future. How much money will I have in my bank account if I invest this way? Okay, so then the next fun part is just typing it in your calculator. This R value sits out here. So please don't try to distribute it into the top. I'm going to work the top first, then divide by the bottom. Okay, so let me get my graphing calculator in here. I'm going to work that top first. So I'm going to type everything into that top. All right, so here is my top of it right here. So I got my 1 plus the rate divided by the periodic time to the power of the periodic time times time minus 1. So I'm going to fill this in for the top now. All right, so there it is filled into my top. So now I'm going to divide by the bottom. But when I divide by the bottom, I'm going to make sure to use parentheses. So when I type it in, I'm going to use parentheses around this, unless you get the actual fraction appear in your calculator, in which case you don't need to do it because you can kind of make it look like what it is. Okay, so I'm going to take that original value there, and I'm going to divide by your 0.064 divided by 12. Double check to make sure I type that right. 0.064. Yep. Notice I put it in parentheses. I didn't get counted with the fraction, so I want to make sure I say, hey, it's divided this way. Okay, so I have $484.58. And then the last step I have to do is times that by that 120. So I'm going to take that answer and I'm going to times by 120. Notice how much I'm not rounding, because when you round a ton in this, you lose money. Okay, whether it's money you're trying to invest and gain at the end, or whether you're paying off a loan, you want to make sure that when you're putting money in, you're trying to pay it off as quick as possible. Otherwise, you're having a lot of interest on it. So please don't round. Please, if you can, go up and like use the decimals before that you find, like I did. Okay, so $58,149.62 will be the answer to that one. Okay, so I went from $120. In 20 years, I'd have over $58,000 in that bank account if I didn't touch it. Okay, so that's just going through it. All right, so my next one. Mr. Michon recently got a $6,000 car loan at 3.5% APR and wants to pay it off in 4 years. How much will his payments be for each month? So if I'm paying off a car, we're using the loan equation. Okay, so the present value one. What is the present value of my car loan payments here? Okay, so if you want to pause the video and go ahead and try to plug into that present value loan equation, go ahead and do it. Otherwise, I'm going to fill it out and then kind of explain where all the numbers came from. All right, so my present value of my car is $6,000. Okay, so I'm initially starting at $6,000. This is the amount per payments, remember? So how much monthly am I putting in, or how many, if I'm paying it monthly, that's what that R is kind of standing for. So it says how much will his payments be? That's why it's R. Each month means I'm going on a monthly basis. So that's what I used my periodic K's for, was the 12s. Okay, I'm trying to pay it off in 4 years, so that's the 4. Okay, so what I'm going to do is I'm going to solve everything in this parentheses set so that I can figure out what this decimal is, to then divide over, because it's R times that gigantic parentheses set. So if I'm trying to get rid of it, I got to divide it eventually. So I'm going to type in my top first and figure out what his decimal is, then divide by the bottom again using parentheses, and then I'm going to end up dividing it over. Okay, you could also multiply this guy over first if you really wanted to. I'm just going to work this parentheses first. So I'll show you my top, and then I'll play it so that you guys can see the calculator that I used to type in the top. Then I'll show you what it is divided by the bottom, and then I'll show you what it is dividing it over. All right, so here is just my top. If you don't get prompted with the exponent like this, you also have to be careful. I would just mentally do the fact that -4 times 12 is -48. Otherwise, you might have to use, especially if you're a TI 83, you might have to use parentheses around that exponent to say that's what you're multiplying together. I get prompted for the exponent, so it's a little bit easier for me, but if you don't, I would either do the mental math to multiply them or use parentheses around the exponent. Okay, so this is my number. I am now going to divide it by the guy in the bottom. So I'm going to pause this here so that I can type it in. Okay, so this is the number that I have dividing by the bottom. Notice I use the decimal from before. Okay, so then let's say I show this, so 44.73, so that you guys can see why we're actually dividing it over. So it's 6,000 is equal to R times that 44.73 decimal. So it's a multiplication. That's why we're going to end up dividing it. So now I'm going to take 6,000 divided by that previous decimal. Please try to not round so much. Okay, so my monthly payments then would be $134.14. Okay, so what's going to be interesting here is to see how much I actually spent. Okay, so let's think about this, $134.14. So my monthly was $134.14. So let's figure out how many months that I actually pay. So there are 12 months in a year, and then I paid for 4 years. Okay, so that means if I take all this, I will have paid $6,438.72 when my car cost me $6,000. So what I actually ended up paying in interest, because I took out a loan, I actually paid an extra $438.72. All right, let's take a look at our next one. Here are the pages that you guys were asked to read about the equations. So based on the recent census data, a logistics model for the population of San Antonio 2 years after 1960 is as follows. What is the initial population and when was that? What will the max population according to this model? And when will the population reach 800,000? Okay, so first off, when you type it in, if you didn't get prompted for the fraction, you have got to use parentheses to say those are together in the bottom. Okay, so go ahead and type it in and adjust your window to be able to actually see the graph. You're gonna have to adjust it pretty big because it's a big number. And see if you can answer these questions. We have the capability to answer them, so go ahead and do that. When you replay the video, I will show you what I used for my graphing calculator to be able to see it, to be able to answer the questions. So go ahead and pause it and see what you can do. All right, so I'm gonna show you guys kind of everything that I typed in so you can see it. So there's my equation. Use parentheses because I didn't get prompted with the fraction. The window that I used here, I did my X max as 400, my Y max is 960,000 so that I could see it. And then here is what my graph looks like. So now going back to the question here, what was the initial population and when was that? So we start at 1960, so I need to know when the initial population is of that. Put my calculator back here. So at time 0, look at my table. Okay, so at time 0, that's going to be when my initial population started in 1960. 36,719 people. Again, don't round up, always round down when we talk about people. Okay, and that's in 1960 because that's when the table starts it. That's what it says in the directions. Okay, the next one here, what will be the max population according to this model? So do your second trace max. When I do this, I try to get close to where I see it kind of teetering out. So I look at the Y values and I see when does it kind of teeter where it's not going higher anymore. So I'm just scrolling. Getting kind of close there. I might have to adjust my window. It's adjusting for me. Awesome. Okay, now I'm just moving in like the decimals. I'm seeing when it actually stops, and then we just teetered out right there. So I don't even have to do my max. That is my max. Okay, so I max out at 934,499 people. That's my max. So notice all I did was trail till I kind of saw it kind of not going any higher, and that's where my max ended up being. So then my last question here, it says, when will the population reach 800,000? Okay, so I am going to put my 800,000 in here and then do my intersection. I got to readjust my window here because it did it all for me. There we go. So second trace, intersect. Okay, so 121. So if it's asking for the years, we started in, I think it was 1960 plus 121 years. Okay, so in 2081, we will be at that population. Okay, so Ricky wants to buy a house priced at $230,000 and he has a 15% to put down on the house. He will invest in a mortgage at 3.25% for 20 years, compounded monthly to pay off his house. Determine his monthly payments. Okay, after we determine his monthly payments, we are going to determine how much he paid for the house. Okay, and then we're going to determine how much would he save if he put an extra $120 a month in it. Okay, so first off, I got to figure out, I'm going the loan route. Okay, so I don't actually use, I didn't take a loan for $230,000 because I put 15% down. So first we got to figure out what is 15% down of 230,000 because I got to take that off. So 230,000. Got to take off my 15% down payment that I put on it, which is 34,500. So this is what I got to take off now because I put that amount down. So I don't actually have the loan for that $230,000. Okay, so 195,500. So that's what I'm building my loan off of. So if I'm determining his monthly payments, okay, that's going to represent my R. I'm going to use 12 for my K's. I've got my interest right here, my time here. Okay, so I'm trying to find R. So I'm using this 195,500. Trying to find R. I'm using my loan one. So 1 minus the rate 0.0325 divided by my time. Okay, with my time and my other time, 20 years, all divided by that again. So try to kind of work through typing it in yourself. Okay, remember this is R times this. So once you figure out that whole parenthesis set, you're going to divide it over to figure out what your monthly payments would be. So I'm going to pause the video and then I'm going to find it and tell you guys the answer. All right, so I actually forgot the 1 plus in here, which if you didn't have that, you're getting an overflow error. So go ahead and try retyping it in. All right, so this is the amount that you should be getting. $1,108.87 would be your monthly payment then. So then our next one, we're going to determine how much we actually paid for the house. So I'm going to take that and figure out all my months and years here, what it's going to be. So to answer B, I'm going to take 1108.87, and I'm going to times it by, we did 12 months per year, and we did it for 20 years. So I'm going to take that, multiply them out. 1108.87, 12 times 20. 80 cents. Okay, so originally I had been spending this amount, so 1,900, 1.500. Let's take it off. So this is how much money we just spent extra interest paying it off over that 20 years. Okay, so then the next question says, well, determine how much money saved if he pays an extra $120 each month. Okay. So the problem is we're going to pay it off faster this time. So what I'm going to do is I'm going to put the $120 in and find the new time that we're actually going to be paying it off to be done with it. So I'm going to take my 1108.87 and add 120 to it. So my amount of my house, here's my monthly payment. Okay, I'm going to figure out my new time it's going to cost me. So I got my 1 minus 1 plus, same rate, monthly. I'm going to find my time it takes me to pay it off because it should get paid off faster if I'm putting more money in. So I need you to, let's go ahead and kind of just simplify here. So I cannot type this in because this T is attached to this. So I can't do 1 minus this. So what I'm going to do is I'm going to kind of manipulate some things over. So I'm first going to get this over. So he's multiplied, so I'm going to divide him. Equal to now this big old mess here. I'm going to find actually the base of that exponent. So I'm just going to type this in and figure out what that decimal is. So 1 plus 0.03 parenthesis 0.0325 divided by 12. Okay, so I'm going to have 1 minus 1.002708333 all to the negative 12t. 0.0325 divided by 12. Okay, so what I can do now is I'm going to multiply this over to the other side. I'm still going to use parentheses. So when I type this in, I'm going to put 159.0892446 times parentheses 0.0325 divided by 12 and my parentheses. Say they're together. So I've got 0.430866741 is equal to 1 minus 1.002708333 to the negative 12t. Must subtract them. Negative 0.5691332959. Okay, this is like a negative 1, so if I divide him, basically he's going to get it all positive for me, which is what I need. So I'm just going to change it all to positive. Okay, now I'm an exponential. I got to convert to log to solve this. So log of the same base, so log of that 1.0027, you can fill it in here. I do my flippy, so my next big number, or his argument, is that 0.569133, and it's equal to the exponent. Okay, so what I would do is I would type this in my calculator first. If you don't have, if you go to math, and then you scroll down, or you scroll down to where mine says A, it's called log based. 83s don't potentially have it, the 84s do. Then you can convert this and find out what his decimal is. Otherwise, you have to do change of base. So if you were doing change of base, you would do log of 0.569133 divided by log of the base. Remember, base on the bottom. Okay, and then whatever that answer is, once you find his decimal, you still have to divide by negative 12. So that's what I'm going to do right now. And I get 17.3634, 17.34 years to pay it off. So let's figure out how much I actually spent then. Okay, so my monthly payments were, well, here, 1228.87. I paid it off in 17.34 years, and there are 12 months in that. So 268,188.07. That's how much I spent. So now if I go back to my other page, okay. All right, so I accidentally typed in 1,288. So if you type in 1,228.87, what you actually have to do is you have to multiply these first. You get like 20, let's see, 208.08. You don't do 0.08 of a month. Okay, so you're actually going to round that to 209. So you're going to take 209 times your $1,228.87. Okay, and now I'm going to take off that amount that I have to the $256,833.83 from my original total, so I can figure out this is how much extra I paid. And now if we subtract it from how much extra he paid here, we actually save around $8,800. By just putting an extra $120 in a month, you save a good chunk of money because of the interest that's getting built on top of it. Okay, so if you want to go ahead and try another one here, here's the last one of these, and then I'll kind of flip the answers so that you can check what you got as well. So if you want to pause the video and go ahead and try this one on your own to see what you get, you can, and then I will flip up the answers. Right, so here are your last answers. So my monthly payment, I got $632.89. My total amount paid is the $227,840.80. So I ended up paying an extra $77,840. How much would be saved if I paid an extra $100 a month? $22,000. So my new monthly payment that I use is $732. When I solve for my new T, I got 23. That's 0.258. With some more numbers, try not to round. Okay. Then I took that, times it by my 12 months, because that's my new time. I got 279, so we can't do point something of a month, so I rounded it up to 280. So I took my $732.89, times it by the 280 months to get $209.20. Took it off the $150,000 total that I was putting in for. I got $55,209. Okay, I took that off of, there's one too many sevens in there. So the amount I paid without the extra $100 a month was at $78,000. So when I take off the $55,000, I'd actually be saving around $22,000.